In this video, we are going to see the prediction of cardiovascular disease using machine learning. Now we are going to see the overview of our process. Cardiovascular disease, that is CVD in the short form, is for the most part alluding to conditions that include limited or blocked veins that can prompt a heart attack, chest trauma or stroke. Cardiovascular resides the number one causes of death throughout the world. The main objective of our process is to detect the cardiovascular from the input data. In our process, the input data set is collected from the dataset repository like UCI or GitHub and so on. After that, we have to implement the pre-processing step. In this step, we have to remove the unwanted data or unnecessary noise from the input data set. We have to use the handle missing values and label encoding technique in the pre-processing step. The missing values means if is there any present in the missing values in our input data, we have to replace the missing values by zeros. Then we have to perform the label encoding technique. The system is developed the machine learning algorithms such as logistic regression and decision tree. Here machine learning algorithm brings a new proposing to cardiovascular disease prediction. That's why we have to choose the machine learning algorithm. Finally, the experimental result shows that the performance metrics such as accuracy, precision, recall and F1 score. Our input data contains the information about the symptoms such as blood pressure, glucose and so on. Now we are going to see the flow of our process. Start. Load the input data. In our process, we are using the cardiovascular disease data set. The data set contains the information about the symptoms of cardiovascular disease such as blood pressure, glucose and so on. Then we have to implement the pre-processing. In this step, we have to use two techniques such as label encoding and handling missing values. We have to remove the unwanted data or noise from our input data set. Then we have to move on the data splitting. In this step, we have to split the pre-processed data into two parts, that is testing and training. One portion is used for predicting the model and other one is used for fitting the model. Most of the data is used for training and smaller portions of the data is used for testing. Then we have to implement the classification algorithms. In this step, we have to use the two classification algorithms such as logistic regression and decision tree. Finally, we have to find the performance metrics for both algorithms such as accuracy, precision, recall and F1 score, and also compare the two algorithms result in the form of graph, that is visualization. Finally, we are going to see the output part. This is our output part. I just explain one by one. Okay, this is our data input data set. So just I will display the few data from our data set. Next we have to check the data frame. This is the our attribute or column name from our data set, and it is the corresponding data type, that is integer. Here it will displayed all attributes from our data slip and corresponding the data types. In pre-processing, we have to check missing values. Here this is the attributes, these are the attributes from our data set, and this is the missing values count. Here 0 means there is no missing values in the attribute or column name id. Similarly, these are. Then the next step is label encoding. Here label encoding, before label encoding, the male or female and normal will above normal. Oh, this is the before label encoding. To perform label encoding technique, that is after label encoding, it will change 101 gender, then the cholesterol it will be changed, and also level glucose. So these are the label encoding. Then we have to move on the classification algorithm. This is the result for logistic regression, and this is the result for decision tree algorithm. The result will be shows that accuracy, precision, recall, F1 score, and similarly. And finally, this is the visualization graph for ROC graph for decision tree and logistic regression. So this is the output for cardiovascular disease prediction using machine learning algorithm. Thank you.